Hi, my name is Chonjo Teokratkashin, and in this video, I show how I make analysis over my two datasets, two federal loan forgiveness program communities by using the SQL, T-SQL for the assignment. Name it. My communities analysis presents findings of the week 6.2 IT1 for D3 class for blocks in St. College 2025. Previously, I presented my two communities that makes my two datasets that are important into my ECIT 143 DA database, teacher loan and public loan services. You will quickly understand that both my two communities originate from the Federal Student Aids data center that's named National Student Loan Data System. This is the national database of information about loans and grants awarded to students under the USA legislation. Okay, let's deep in our analysis, and I will begin with the teacher loan forgiveness. These are for the key 12 teachers eligible for a separate loan forgiveness program offering up to $7,500 in relief. Yeah, it's from the Federal Student Aids, which is an official USA Department of Education tracking annual metrics from fiscal year 209 to 224, comparing two parallel loan systems, the FFELP and direct loans, or Federal Family Education Loan Program, that was offered by the private standards, and the loan program that was offered by the Department of Education. Stakeholders for this dataset are US teachers, Department of Education, FSA or Federal Student Aid, USA school districts, and policymakers. Key fields for this dataset are fiscal year, dollars for both programs, fiscal year, dollars for both programs, and borrowers for both programs. Okay, the first question is for trend comparison. So what is the trend in total dollars forgiven across both programs, and which program shows more consistent growth? This first question for teacher dataset will compare overall scale of forgiveness. Which program shows more consistent growth? Yeah, the goal is to compare program scale growth stability. So I will do that by using the select clause that will select rows points for both programs, the dollars forgiven, and visualize the trend. Let's go and execute this first portion of code. This is a straightforward select statement, simply retrieving the dollars forgiven for this program and this program, yeah, by ordering by years. So I will execute. Okay, this is the result, and from this result we see that the direct loans show a strong consistent upwards growth in dollars forgiveness, while the FFELP forgiveness peaked around 214 and has been in sharp decline ever since. Okay, second question: how much forgiven per borrower is provided in each program, and how does this ratio change over time? So this is to analyze per borrower metric. Yeah, and the goal is to determine the average values of forgiveness grant over the time per a borrower. So I will calculate this average for both programs in a single query. Okay, let's go and see our code. This is our code over here. Here I use arithmetic operations within the select clause to perform division for both data. I use the null function 0, which safely prevents a divided by 0 error if the borrower's count was ever 0. Yeah, I will directly execute this portion of code, and we see the results. The average forgiveness amount per borrower for both program over time, indicating a potential increase in average teacher loan burdens. Okay, next we will try to understand the participation shifts. Our question is, why has the Federal Family Education Loan Program borrower participation declined sharply after the fiscal year 2015, and how does this compare to direct loan growth? Yeah, this final question for this data uses the SQL to quantify the decline. Yeah, why has FFELP borrower participation declined sharply after the fiscal year of 2015? The goal is to quantify and understanding policy shifts. So I will use the square to measure the exact annual change in borrower counts for both programs simultaneously. Okay, let's go on, and this is our code, and in this code I use the lag functions for both FFELP borrowers and the direct loan borrowers to access data from the previous row or previous fiscal year and calculate the changes between consecutive fiscal years. I will execute. Here we have the results. The total borrowers per year for both programs, and here we see previous records to compare with the actual records, and here we have changes. We have the difference over here. Yeah, and we can quickly see that there are strongly implies a policy driven shift. The decline in FFELP participations directly corresponds with the with strong growth in the direct loan program. Okay, next, to finish, my fourth question is for borrower counts for the fiscal year 2009 to 2024. How does borrower count differ between FFELP and direct loan programs over fiscal year, over this range of fiscal years? So this final question use SQL to compare program reach. How does borrowers count differ over fiscal years? The goal is to compare the program reach. So to get this difference in terms of borrowers between out two programs. Okay, let's go on and execute our last question. I have a simple select statement in which I do arithmetic. Direct loan borrowers minus FFELP borrowers. So I will execute, and here we see the difference. Yeah, the difference for both programs. Let's go forward for our second program, the Public Service Loan Forgiveness Community Dataset. This community dataset focuses on the Public Service Loan Forgiveness Program. This initiative offers forgiveness on federal loans after a public servant makes 120 qualifying payments. Yeah, it's from the National Student Loan Data System. Key stakeholders for these datasets are the borrowers, the Department of Education, and loan servicers. So this data provides a transparency into the certification process, which has historically been a point of friction for borrowers. So key fields for these data sets includes calendar year, query or question, total approved forms, and total deemed forms, and cumulative borrowers. Yeah, you can see this over here. Okay, these are our fields. Our first question for this first analysis, program accessibility and approval rates, I combined the question number 1, the first question, and fourth question. So I will explain why. We see that for the first question, it was for fetching the total approved forms and total deemed form to evaluate accessibility, while the fourth question was to find total approved form and total deemed form to calculate approval rate. So you will understand that these two questions interferes. So I will directly use the fourth question that's found the both total form approved and deemed and calculate the rate. Okay, this question sets aimed to evaluate program accessibility by looking at approval rate. So the goal is to evaluate program accessibility and efficiency. To answer this question, I use the SQL to aggregate approved and deemed forms by year and calculate a precise approval percentage. And this is our codes. I grouped by calendar and use the sum aggregate function to combine quarterly numbers. Yeah, the cast function ensures my calculation is formatted correctly as a decimal percentage. So I will execute. This is the results, and from these results I created this sharp, and we see that the approval rates constantly remain above 50% for most years in this data set, highlighting a consistent success of the program. Yeah, next, this is the next question for this data set that asks for participation growth trends. Yeah, what is the year-over-year growth rate in cumulative public service loan from borrowers from 2012 to 2018? Yeah, this question shifts focus to participation trends. The goal is to see the participation trend and the growth trajectory. So we need to compare each year's total to the previous year total. And this is our codes. I select calendar year, maximum cumulative borrowers. By grouping them by year, by calendar year. I use the lag function that is essential to access data from the previous year or arrow in the result set to calculate the growth rate dynamically, as they are grouped by year and sorting by year. Next, this line of codes calculate the percentage change between the current year and the previous year. We see the lag function here of this year or per year. Next, I use the naive function 0 to prevent the divide by 0 error. And we see the where clause that filters the rat include only records falling within the precise range of years. Let's execute. This is the results. Yeah, we have the number of borrowers and the difference of the previous year and the year-over-year growth percentage over year. And you can see that in 2050 the number of borrowers considerably grown. Thank you for watching.